when man, that's distracting.
How distracting.
Okay.
I just
Um,
won't share screen. It's what's
okay.
causing
So
it.
where I was getting at was okay, so on the one hand, we have this discretization and this continuity, and on the other hand, we have this embedding of the discreteness within the continuity or the continuity within the discreteness. Or there's like nestedness, right? Where you have like discreteness, continuity, continuity within the continuity, and so on and so forth. But also, while we have the prioritization of what's happening, there's also kind of like a tuning aspect, right? Like the tune, like there's tuning mechanics happening, right? Like when you think of stuff like hyperplanes and or hyperparameterization, I think a beautiful paper to look at is biological cognition by I think it's Hubner and Shulkin, and they bring up this term called heterarchical processing, right? And heterarchical has to do with like selective tuning, or you think of like you're an audio engineer and you're mixing. You have a mixing board and you're trying to get the right, trying to mix the channels and all that together the right way, like this tuning or this adaptive tuning rather. But it's like there's like a mix of there's layers of the hierarchical and then the tuning happening, right? So it's not, even though I would argue it's mostly hierarchical, you still have this tuning happening, right? You still have this sort of like this degrees of tuning happening, but I'm not sure if that I like I already am like about I'm on chapter 5 right now, just finished chapter 4, but I'm not sure if the book really addresses like this hyperparameterization issue, but I guess you can kind of go over that if you can.
Yeah. Yeah. That's I think that's a really interesting point too. So whenever and I want to find the figure, I don't have it top of mind, but it's in the second half of the book, and it might be in the section on learning. But what everything you're saying about like tuning and hyperparameters, those are absolutely like those are component like directly components, not just figuratively in active inference models. And so what you can have is like I mentioned precision earlier, that came up at the end of the chapter, this chapter. But you can actually like precision can be modulated such that it impacts the rest of the model. Once you have a hierarchical model, it's like it's not just, every once in a while something happens here, but most of the time it's over here. It's like the whole model is integrated, right? And so you do have this really strong constant interplay um, between the different layers. So that hopefully at least figuratively gives you some sense of like the way you described like a continuous and the discrete and the discrete and the continuous. It's like, well, as far as like coding a simulation, you do have to more clearly define one versus the other, at least at each layer. But then that said, they're so tightly integrated, it's as if, the discrete is impacting the continuous in any given moment, and vice versa. And so that's there. And then somewhere in the textbook, there's another figure showing the POMDP we were looking at earlier, but it also adds on hyperparameters, and those very hyperparameters are what can be adjusted or tuned, and they relate to precision. For example, you could have your agent learn its A matrix, meaning the likelihood matrix, which figures in this chapter. And so they might learn to, let's say we have our mouse in the T maze, the agent, right? Let's say they repeatedly go through the maze over and over, and through trial and error, um, end up learning that the stimulus is always on the left. Let's say we're the experimenters, we could choose that. Let's say the stimulus is always on the left. For an agent who undertakes or engages in learning, um, it's not only going to try and minimize its free energy, its variational free energy, but it'll actually start to modify and change its beliefs within that A matrix to where it'll start to associate the cheese or the attractive stimulus with the location left in the maze, right? Its belief about that. And so that's how that plays in, the kind of tweaking to the models and so on. So we have learning, and something like hyperparameters here in the case of precisions are directly implicated. So all that is here, but that's a really interesting paper that you brought up. I almost feel like other folks, other members of the institute might find some interest in that. Um, I found something hierarchical control mechanisms in biology. Does that sound right?
Yeah. Um, if there's like any resources you have to suggest for me to look into, I'd love to take a look at it because I haven't really found something other than that one paper I mentioned. Well, it's biological by cognition. I think it's published through Cambridge. Yeah, it's the one through when you look it up, biological cognition, it's the Cambridge article. It's paywalled, but I was able to get a copy of it.
Nice.
But
Yeah.
I hate when like really nice papers are paywalled. It's like, oh, it's such a crime, you know. It's
Yeah.
anyway, yeah.
Yeah.
I mean, I'm always looking for more papers that talk about this hyperparameterization stuff. Because I feel
Mhm.
like there's just not enough out there explaining that. There's so much stuff talking about hierarchy and like embedding things in hierarchies. And even though I would say like the hyperparameterization requires hierarchical stuff in order to be effective, it's still not hierarchical in its nature. But yeah, like definitely throw it at me. I'm Catmandu on Discord, so if you want to DM me that those resources if you find them, or even share it in one of the channels, I'll definitely. I'm constantly eyeballing what's shared on the server. So
Yeah. In for the relationship between discrete and continuous, in the machine learning paradigm, what they actually use is a mechanism called CLIP, which is it's simply going to take the energy relationship between this categorical and this discrete thing, and then just throw it in whatever's easier, which happens to be language in our case for large language models. So what you do is you find the most straightforward abstraction layer. This is going to be naturally hierarchical if we're talking about deep learning in this specific example. You create that abstraction layer, and then you just keep it consistent through the entire thing. Two other things that might be related to what you're talking about is Anthropic's most recent paper, which I've forgotten the name of. I'll have to find it. But they essentially talk about not hyperparameters, but the expectation of the actual state that you're putting into it, which they define as a feature. A feature is going to be deeply related to what we consider to be a concept, like a dog or a cat or something like that. And being able to take these concepts, which kind of create these little bubbles that you can create a context around. There is some situation that it's talking about, which has some set of features which are going to be activated. How much you activate these certain features are going to be deeply related to what you're saying about these hyperparameters. So deciding which hyperparameters to use is going to be found right now in machine learning through the creation of, do we make this feature really big? Do we shut these features down to be really small? And that's going to be how we control how these hierarchical mechanisms are actually going to consistently be able to produce the results that we're looking for. One other slightly related thing is of the application of going through the network and having a kind of a meta network decide what inside of the network to actually create. This is going to be a very recent paper called, it gets into a bit of the weeds, but it's a mixture of a million experts, which essentially takes the entire hierarchical network that we're going to be dealing with, and all of the variables are going to be encoded into these one layer MLPs, these one layer fully connected networks. And from there, we're going to find a way to create a meta network which decides which ones to turn on. And these ones that I'm talking about are going to be analogous to hyperparameters. And it's taking a large network, which again talks about the context that you're speaking of, and being able to decide which ones are important, which facts are important inside of what we're talking about, and only turning those on. which I think is deeply analogous to the hyperparameter thing. But that does lead me to a question of whenever we're talking about hierarchies in the active inference domain, how much does it matter? You guys were talking about system one earlier. How much does it matter with respect to continuous or discrete variables? Once you get past the system one level of the direct input from the external environment that you're trying to understand, do you guys think that once you enter into a hierarchy, it's all just abstracted away? Or do you guys think that the discreteness or the continuousness of the actual input is going to have really deep ramifications as you go down the line? I'm sorry if that was a lot.
Great comments. We'll each just give a short closing thoughts in these last minutes. I mean, shortest answer, it's simply 100% dictates it. It's like asking about a transistor. How would it matter what the composition of the metal is, or how would it matter what the size of the plate, or how closely these elements are? It's like it simply determines it. So then there might be some situations where you could discretize a continuous and get this or that performance retention, or the other way around. But that's kind of the fun, is the textbook is just showing us those fundamental motifs. And Toby Smythe in the structured active inference live stream earlier today showed that in a far more comprehensive way than the Markov blanket formalism with the broader applied category theory for interfaces. So it's like all about how it's specified, like a physical transistor or a Linux kernel deployment.
I also this I don't know if this is a little too simple relative to what we were all just discussing, but I did drop a link to one paper into the chat there, and that is deep active inference and scene construction. And just given we have such little time left, I just wanted to drop something there as as a kind of combination of things we're talking about, including hierarchical modeling. Um, and here, the idea of like looking at particular features that, when combined, maybe allows for, let's say, classification or categorization of, in this case, the paper I shared, like a visual stimuli. It's rather interesting. They put together a two-layer model where it's like a saccade experiment. So it's like someone is viewing a 2 by 2 grid, and then they make inferences based on particular things that they see um, in each of the coordinates of that 2 by 2 grid. And then they, from there, have to infer certain aspects of what's going on in each of those two grids. And then that gets pushed up to a higher discrete level that allows them to make an inference as to how they should categorize the entire scene, the entire 2 by 2 grid, like what is going on there. It's based on a previous experiment that's very similar, but it would just be it's a way to kind of simplify a lot of the principles we're sort of talking about here, um, but also being able to see something like trying to theorize like how does scene construction happen. If you look at a broader expanse and you're trying to figure out, like, infer a belief about what is going on there, well, your eyes are limited, and so they can only look at certain points. So how do you start to construct a belief about what the overall scene is based on particular features that you look at? And you have to make inferences about those individual features in the first place. So, for me to look at an overview of like a street, and I don't know exactly where, that is in the city. I have to look at different parts of the overall image. I have to infer, oh, that's a particular sign, that's a particular building, and so on. Eventually move to the higher order inference of where am I? What is this location? So I just thought that one would be interesting. I'll try to add other things that maybe come to mind in the coda. Um, and yeah, really, really interesting talk today. So thanks,
Cool.
everyone.
Thank you, fellows. See you
Yeah,
later.
thank you both so much. Bye, guys.
Bye.